Okay, the diagram shows a cylinder. Cylinder's radius r and height h. Points P and Q are on the circumference at opposite ends of the cylinder. Point P is vertically above point Q. By considering the net of the cylinder, find an expression for the shortest distance from P to Q when travelling around the cylinder. Okay, so you could see here that P is vertically above the point Q. I think that's sort of really important there. Okay, and we need to look at the distance, don't we, between P and Q. Okay, so that it actually travels around the cylinder, but the shortest distance as well. Now, when you look at this here, it's as if there's like a string going around the cylinder. Okay, joining P to Q, right around. But if we were to look at the net of it, when this is all stretched out, that should actually form a straight line if it's the shortest distance, if you think about it. Even though it's sort of curving around here, when I stretch it out, that will be a straight line in order to get the shortest distance. Let's draw the net. The net will really help us see how this sort of is working out. Okay. Now the net of the cylinder. Okay. Now for the sort of face bit here, okay, this main bit here, actually it's a rectangle if you think about it, right? You might not have thought about that as a cylinder, but this bit here, if you've got a can of baked beans and you chop it up, you realise the side face here, when you roll it out, is a rectangle. Okay, so you could do it with a toilet roll, couldn't you? You could cut it and then you could stretch it out, and it would be a rectangle. Okay, so that would give you the face here. Now we need the circular faces at the top, so what we would have is this circular face here would be at one end. Okay, now I'm pretty good at drawing circles, but it would be something like that, and then the other circular face would be at this end here. Okay, alright, so that's how it works. If you were to roll that around, then these sort of the top and bottom then would sort of fold in, and you've got your net then of your cylinder. Now, as I said, the important bit here, it said here about P being vertically above the point Q. Now, if that's the case, when these meet, this edge here would meet with this edge here, if that makes sense. When you roll them, you roll it up, this edge here would meet with that edge. And if P is vertically above Q, well then P would possibly be here on the circle. Q would obviously be here. Okay, so that when you roll it round, this edge here meets with this edge. Okay, to sort of form this tube, and P would be vertically above Q. Now, when it's stretched out, as I said, we'd want this distance here. Okay, and it would be straight distance. To get the shortest distance, it would be straight. So we want that there. Of course, if you look at this here, we've got a triangle, haven't we? If you notice here, a right angled triangle being created, and you might be thinking, well, to get that distance there, maybe we could use Pythagoras. Okay, and that's exactly what's going on. Now, for in this case here, now we need to work out some of these things here. Now, what would this be here, for instance? Okay, what would that length there be? Now, I know that length there. That length is just this here, isn't it? Okay, that length is this, and that's just the height, isn't it? And it's called h. This is the height of the cylinder, so that's h there. The key then is, well, what's this? This is the key part as well. What's this? Well, don't forget now, this would fold around, and it would create this, wouldn't it? This here, the circumference of the circle. Okay, so we need to work out the circumference of the circle. Now don't forget, circumference is pi times d. Okay, pi times diameter. And do we know the diameter? Well, no, we know the radius, don't we? The radius is r. Okay, so that would be pi times diameter, and diameter is twice the radius. So be pi times 2r, 2 pi r. Okay, some people think of learn circumference as 2 pi r. So we know this then is 2 pi r. So look, we've got that side, we've got that side. We could work out PQ, can't we? We could use Pythagoras' theorem. And don't forget Pythagoras' theorem, CAB, C squared equals A squared plus b squared. That's Pythagoras' theorem, or a squared plus b squared is c squared. It doesn't matter which way you say it around, this will be perfectly fine now. So c squared will be a squared, now a in this case is h, so h squared, plus then b squared, which is this. Now all of this needs squaring, so I need to put it in a bracket. Okay, so then work that out, h squared. Now if I do this, I need to square all of this, don't forget, so that'll be 2 squared is 4, pi squared is pi squared, and then r squared. Okay, so that'll be there. And then they want your expression in terms of pi, h and r. They want the distance, which is c, so all I'm going to do, of course, to get c, then I need to take the square over and square root the whole thing. Okay, and I've got my answer in terms of pi, h and r, and that's it. Job done.